Okay, this is the video version of the key to Formative 6a. We're going to get started right away. On number 1, we're trying to find the degree measure of an angle who is pi over 15 radians. Since I want to take it from radians into degrees, I'm going to multiply it by a conversion factor. That conversion factor should have radians in the denominator and degrees in the numerator, because then radians will cancel. There are 180 degrees in every pi radians, so I can just multiply this and find my results. I can see already that pi will cancel, and I'm left with 180 over 15. Simplest way to do that, and you guys did have a calculator for this, so I would have gone, you didn't have a graphing calculator, well yeah, actually you had a graphing calculator even. So 180 divided by 15, 12. So C is the correct answer here, that's 12 degrees. You did okay on that one. Number 2 was a pretty poor performance. 24% of you chose option E. So again, we got 105 degrees, and we're going to actually multiply that. We wanted to get rid of degrees, so that's going to be in the bottom, and we want to get radians, so we're going to put that in the top of our conversion factor. Let's see, again, 180 degrees in every pi radians. So I've got 105 pi over 180. And I can just go ahead and, I got two options here. I can either just go ahead and do 105 divided by 180. It's going to give me a decimal, but then I can just go to math, frac, enter, and it's 7/12. So we got 7 pi 12ths right there. That's letter D. You also could have just kept reducing this. I can tell already that 5 goes into both of those. So when I reduce it by 5, I guess I get 21 over 36. And then I can divide them each by 3, and that's where 7/12 comes from. So both of those are ways you could get that done. Now we need the reference angle for an angle whose measure is 115 degrees. 115 degrees is a little bit to the left of 90, so there's 115 degrees. The reference angle is to the closest part of the x-axis, which is right here. So we should just simply do 180 minus 115. That's going to leave us with 65 degrees. So that is option A. I know I'm going relatively quick. I'm on a free version of a program that only allows me to record for 15 minutes, and I know I got a lot of stuff to take care of down below, so we're going to go as fast as we can. An angle between 0 and 360, that's coterminal, and so here is -2 degrees right here. And so if we had gone all the way around instead, that would be 358 degrees. Another way you could have just done it is taken -2 and added 360 degrees. That's where we get 358. Okay, number 5. This is a spiral standard, but one we've done before and done quite often. And so if we want to find f of g of x, we need to plug the g function in for the input of the f function. So we should write 2 over x over 2 over x plus 6. Get this out of here. That would mean we want to simplify this. You got a couple options here. One is you can just plug in some values for x and figure out which of these multiple choice options works. That's an ACT skill we've talked about. But the other one is, the simplest way is to multiply this by x over x here, because 2 over x times x will just be 2. Do the distributive property in the bottom here. 2 over x times x is again 2, but then I also have to multiply it times the 6. So I get 2 plus 6x here. Now everything can be reduced by 2, so that gives 1 over 1 plus 3x. That is option E. 21% of you chose option C, so either, I don't know if it was a guess or if it was just incorrect canceling, yeah, we got 1 over 1 plus 3x. Which of the 6 trigonometric functions has a value of radical 34 over 3? So let's finish off the triangle here. We gotta have our right triangle so that we can reference this theta here. This is the reference angle, and this is 3. This is -5. When we do the Pythagorean theorem, we've got -5 squared plus 3 squared, so that's 25 plus 9, 34. We got to square root it because that whole time was equal to just c squared, and so the hypotenuse is equal to radical 34. So we got to figure out which of these represents that value. Sorry, I don't know what just happened. Ended up in the wrong place. Here we go. And so let's see. Which of them equals radical 34 over 3? So radical 34 is the hypotenuse, it appears. 3 is the adjacent side. So that looks like the reciprocal of something that has adjacent over hypotenuse. This looks like the reciprocal of cosine. The reciprocal of cosine is secant. So this is secant. I'm guessing that since 22% of you chose cosecant, you thought cosecant was the reciprocal of cosine, but really it's secant that is the reciprocal of cosine. All right, which of the following angles have reference angles of 30 degrees? Let's check them out. Negative 570 degrees. Well, let's figure out what that is. Take negative 570. I'm going to add 360. I'm going to add another 360. So that's 150 degrees. Negative 570 is 150 degrees, which is right here. And that does have a reference angle of 30 degrees because 150 is still 30 degrees short of the x-axis. So option 1, I would say, is yes. Negative 150 degrees. So if we go here, the negative 150 degrees, so we went clockwise instead of counterclockwise, that still leaves us 30 degrees short of the x-axis. So that also has a reference angle of 30 degrees. 60 degrees. 60 degrees will definitely not have a reference angle of 30 degrees because it's not 30 degrees from the x-axis. We're going to cross that off. 120 degrees. Same thing. That's actually a 60 degree reference angle because it's 60 degrees away from the x-axis, so not that. And then 330 degrees is right down here, so 330 degrees does have a 30 degree reference angle. So we should have got 1, 2, and 5. 1, 2, and 5 is option E. Many of you put 2 and 5 only, skipped option 1. 50% of you, in fact, chose D. And so I don't know if you didn't think that negative 570 degrees, maybe you just didn't know what that angle was, but we can keep finding coterminal angles by just adding 360 until we get to an angle that is something we were familiar with. And as we did that, we ended up finding that it was, I forgot, 150 degrees. And we know that that has a reference angle of 30 degrees. So go the next step on that next time. Okay, most of you did pretty well doing this portion of the unit circle. And so I'm going to pause here and just do it real quick. Okay, so I'm back. I did see a few of you switch these coordinates here. If you're mixing up these two coordinates, you got to recognize that the x is longer than the y here. The x is all the way out this way. The y is definitely shorter than the x. And radical 3 over 2 is bigger than 1/2 because radical 3 is bigger than 1. And so if you're ever mixing those two up, realize that if the x is bigger, it's got to be the radical 3 over 2. In this one, the x was shorter, and so that's why the x was the 1/2 this time. The y was the bigger number, and it was radical 3 over 2. Also noticed a few of you mixing up these two coordinates up here. That's not just something you have to memorize. Think about it. I mean, if we go 1 to the right and haven't gone up or down, our coordinate should be 1, 0, not 0, 1. Okay, our biggest problem was down here with these. So let's go through these as quickly as I can here, just because, again, time is an issue. If you have more questions, come and talk to me. But we'll go with the sine of negative pi over 4. Remember, I don't really draw always the whole unit circle. I focus on the one I need right now. And the one I need right now is negative pi over 4, which I know well enough is negative 45 degrees. And so it's radical 2 over 2 here. Because I'm down in the fourth quadrant, the y is negative radical 2 over 2. And so the sine of that, and the hypotenuse is 1, because we'll go ahead and be on the unit circle here. The sine of that would be opposite over hypotenuse, so just negative radical 2 over 2. Now we need the tangent of 150 degrees. I know 150 degrees is a 30 degree reference angle over here. And again, if I'm wondering which one's the longer of the two sides, radical 3 over 2 is bigger than 1/2. So the adjacent is radical 3 over 2. The opposite is 1/2 because the adjacent is longer than the opposite. I can tell by the way I've drawn it. Hopefully you're drawing it well as well. This adjacent side should be negative here, negative radical 3 over 2 because we're going to the left. Hypotenuse is 1. Tangent is toa, so opposite over adjacent, so we have 1/2 over negative radical 3 over 2. We have to do some copy dot flop there, so I'll go ahead and write 1/2 times 2 over negative radical 3. The 2's cancel. I get 1 over negative radical 3, and that simplifies to negative radical 3 over 3. That should have been our tangent, negative radical 3 over 3. All right, cotangent of 3 pi over 4. I'm going to do some erasing because 3 pi over 4 is in the same quadrant I was already in. 3 pi over 4 is another 45-degree angle. It's three of the initial 45s, so 3 pi over 4 is over here in the second quadrant. And this is negative radical 2 over 2. This is radical 2 over 2. Now, cotangent is the reciprocal of tangent, so it's adjacent over opposite. But look how adjacent and opposite are the same value, the exact same value. When you divide something by itself, you should get 1. But in this case, you should get negative 1 because one of them is negative, so we get negative 1. Finally, we'll go ahead and do a sine of 270 degrees. That's down here where we have an x value of 0 and a y value of negative 1. If you want to try to think about it a couple different ways, you can, but remember, on the unit circle, the sine is just the coordinate of y. Y is negative 1 here, and so we get sine is equal to negative 1. That's all we needed. So this is something that many of you need to practice. Less than 50% of us got all 4 of these right. I don't know, honestly, I think maybe 10% of us got all 4 of these right. So this is something we need to practice. If it helps you to just draw the entire unit circle first and then try to evaluate these, that's fine. If you just draw the triangles like I'm drawing them, that's fine as well. In fact, whatever works best for you, it works best for you. So let me know if I can help you with that area. Number 10, you guys did better on number 10 than you did on anything else. Graphing went really well, actually. So we'll just do this quickly. We had x and sine of x. That'll be 0, pi over 2, pi, 3 pi over 2, and 2 pi. The sine of that would be 0, 1, 0, negative 1, 0. We're going to have an amplitude of 3, and so let's just turn those into 3's right now. That's easy enough. We have a period that is equal to 2 pi divided by 2 pi. So our period is just 1. Now some of you know well enough that that means all you have to do is create the values between 0 and 1 and then divide it into 4 pieces. But what I taught in class had us take and basically divide away this 2 pi from each of our x coordinates. As we do that, we can look at it over here. 0 divided by 2 pi is just still 0, so that coordinate is still there. Pi over 2 divided by 2 pi is actually just like multiplying by 1 over 2 pi. The pi's cancel and we just get 1/4. So it's 1/4, 3. Then we have our next one, so we're going to take pi and divide it by 2 pi. Those pi's just cancel and we just get 1/2 for the next coordinate. Then we've got 3 pi over 2 divided by 2 pi. So I can just reciprocate that and multiply like this. And so the pi's cancel and we get 3/4 for the x value that goes with a y of negative 3. And then lastly we have just 2 pi divided by itself. So we're going to end at 1, 0. So we have 0, 0. And I'll just kind of put my scale as I go. 1/4, 3. 1/2, 0. 3/4, negative 3. And then 1, 0. And there's my pretty sine graph. Okay, moving on to the next one. Terminal side of angle C is on the point negative AB. How would you find the value of angle C? Well, many of you did not draw a sketch. That could help, I think. So negative A is the x value. B is the y value. So let's just call it negative AB right there. We would draw that. So this is the angle, theta, that we would be looking for. This comes straight down to the x-axis, and this has a value of b. So the only way we could find theta is if we found theta's reference angle first. We had no need to use... We had no need to find the hypotenuse, so we didn't use the Pythagorean theorem or anything here. All we simply needed to do was to do inverse tangent of b over negative a. That would give us the reference angle. Now that reference angle is in the second quadrant, so we would have needed to take 180 minus the reference angle. And that's how we would find theta.